Hello, in this lecture we'll discuss something really important. It is about polymorphic objects, and they are the support of software evolution. The goals of this lecture are the following. We will speak that what is polymorphic objects and why they are key to software evolution, and then what about them in statically typed languages. And then we will see that in this kind of languages, we will need the concept of interface. So let's start with an example. So here we have a hierarchy of classes, shape, which is the root of the hierarchy, and then we have different kind of shapes. We have a circle, rectangle, triangle, and all of them implement the same message, draw. So it means that we have a polymorphic API there, draw, and we can manipulate any kind of shape. Okay, and now we have a client, canvas, that implements the method display, and inside this method, we will manipulate a collection of shapes by sending each of them the draw message. And now each shape will answer accordingly because of the lookup. And now the question is, how can we support rhombus in this kind of design? Solution 1, it's easy. I can add a new class in my system, a new subclass of the shape class that implements the draw message. So I will redefine the draw method, and now it will work perfectly. But if I cannot subclass the shape class, because, for example, it could be a third-party class, or it could be another library, or it could be a final class in the Java programming language. So it means I cannot introduce this link. So rhombus cannot be a subclass of shape. And I can still create this rhombus class. I can still implement the draw method in this class. So it means that it should play nicely with the canvas. And if we look at the code, if I implement the rhombus like that, it will answer to the draw message, and it will play nicely. I can introduce some rhombus instances in the shapes collection, and it will work perfectly, even if the rhombus is not a subclass of shape. So what does it mean? It means that producing polymorphic objects is good for the substitutability point of view, and it's key to software evolutions. So it means that if I have some existing code, I can inject new kind of objects in this existing code, and it will work perfectly if they answer to the polymorphic API. And objects do not have to be from the same hierarchy to work together. They just need to implement the same polymorphic API. Okay, in dynamically typed languages, this is usually named duck typing. It means that if an object walks like a duck and quacks like a duck, then it's a duck. It works perfectly like that. And now what about statically typed languages? In those kind of languages, for example, if I declare a variable s of type shape, it means that this variable can contain either an instance of shape or one of its subclasses. So it means I could also write s equal new circle. And it works, okay, because circle is a subclass of shape. And if I want to implement now a rhombus as a subclass of shape, it will work. But if I cannot, because, for example, shape is a final class or whatever, or I cannot doing that, so it means that when I will try to do shape s equal new rhombus, it will not work at all. I cannot do that. So what can I do? And in fact, in statically typed languages, they introduce the concept of interface. An interface, as a name, defines a type as one or more supertypes and contains a group of methods. And we might introduce some default implementation for some methods. And why this concept is needed? Because it allows developers to define subtypes out of class hierarchies. And it can be used by the type checker to check subtypes relationship without the support of classes. Let's see it on an example. Now I define a new interface, iShape. Inside this interface, I declare the draw method. So it means that now the shape class can implement this interface. And what does it mean? It means that I must implement the draw method inside this class. This is mandatory to fulfill the requirement of the iShape interface. And from the client point of view, in the canvas class, it means that now, when I want to manipulate a collection of shapes, I will declare a collection array list of iShape and not shape, the interface name. So it means that any object instances of any class in the system that implements the iShape interface can be added in this collection. So, given this design, it means that now I can implement a rhombus class that extends the object class and not the shape one, and implement the iShape interface. I must implement the draw method inside this class, and it will work perfectly from the client point of view, because now I can introduce some rhombus instances inside the collection in Canvas, and it will work perfectly with the Canvas. So a class must implement the method mentioned in the interface. This is what we saw. The draw method must be implemented in the class that implements the iShape interface. A class may implement many interfaces. So this is not like inheritance. This is not a single superclass. And an interface may be composed of multiple interfaces. So from the typing point of view, it means that now when I declare a collection, a type like that, it means that here I'm restricting the possible solution, the extensibility of the code. Here I can only introduce in this collection instances of the shape class or one of its subclasses. Whereas in this solution, I can introduce in this collection any instance, any object in the system that its class implements this interface. So this is a more open design without restricting the evolution. But don't be confused. Interfaces are nominal types. So it means that we give it a name. It is declarative. And this is very different from the duck typing that we saw in the dynamically typed context. So type compatibility in this context is defined and based on the name of the type. And two interfaces are only compatible if they have the same name, regardless of their contents. So it means that if I define two different interfaces with two different names, but the same contents, the draw method inside, they are not compatible. So this is not duck typing at all. As a conclusion, polymorphic objects are key to support software evolution. If you don't want to break your client code, you need to provide polymorphic objects to inject into this code. And then it's much better to code against an API. You should focus on the API instead of the typing relationship. This is much better from the evolution point of view. In dynamically typed languages, polymorphism is free. So it means that if two objects are compatible from the API point of view, because of the typing, they are substitutable. In statically typed languages, this is not true. You need to define some interface to create polymorphic objects. And this is related to the adapter design pattern that allows the developer to wrap objects to make them compatible from the API point of view.